Then be prompted to insert a flash drive into the Type A receptacle. If you have a flash drive available, insert it in the receptacle. When you insert a flash drive, the demo will read the volume label and the root directory of the flash drive. It will display the volume label at the top of the display and the contents of the directory in the list box below. Subdirectories are displayed first, as indicated by a preceding folder icon, followed by a list of files. Use the up and down touchpads to scroll through the file list. To explore the directory structure of the flash drive, select a directory using the up and down touchpads, and then touch the center touchpad. The current working directory will change to that directory, and the files in that directory will be displayed. To go up to the previous directory, select the ... directory and touch the center touchpad. When you are finished, touch the left arrow touchpad to exit this portion of the demo and return to the main menu. The PIC24F starter kit includes a demonstration of using 3 output comparators and peripheral pin select to control an RGB LED. From the demo's main menu, select Demos. Then select RGB LED from the demonstration menu. The demonstration program will enable the RGB LED at the top of the demo board and allow you to configure the red, green, and blue components of the color. Each component is controlled by an output comparator configured as a PWM output. Each PWM output is mapped to 2 output pins using peripheral pin select, increasing the drive strength and therefore the brightness of the LED. Use the up and down touchpads to select which color to modify. Use the left touchpad to reduce the color content by increasing the PWM duty cycle. Use the right touchpad to increase the color content by decreasing the PWM duty cycle. Most PIC24F instructions execute in a single instruction clock cycle, with branches and comparisons requiring only 2 or 3 cycles. With a top speed of 16 MIPS, the PIC24F has plenty of processing power for a wide variety of applications. For example, graphics output is a very CPU-intensive operation, but the PIC24F simultaneously can monitor the user input touchpads, plus an additional input channel, and display the additional reading in graphical format. From the main menu, select Demos. Then from the demonstration menu, select Graph. The demo will monitor the potentiometer at 10 millisecond intervals while monitoring the touchpads and displaying a scrolling graph of the potentiometer readings. Twist the potentiometer on the right side of the demo board and watch as the readings are reflected on the display. To increase the display speed, touch the right touchpad. To decrease the display, touch the left touchpad. When you are finished with this demonstration, touch the center touchpad. Often, an application wants not only to monitor data, but to store the data for later analysis. By using the PIC24F's USB embedded host capability, an application can store data to a USB flash drive for easy transfer to a PC for analysis. To see this capability in action, select Demos from the main menu. At the Demonstrations menu, select Capture. You will be prompted to insert a USB flash drive into the Type A receptacle on the right side of the demo board. Insert a flash drive to begin data monitoring and capturing. Except for the title, the display looks identical to the graphing demonstration. The touchpad controls are identical. The left arrow slows the display, the right arrow speeds the display, and the center touchpad exits the demo. The difference is that while the graphics display is being updated, the potentiometer readings are also being stored to the file capture.csv in the root directory of the flash drive. Let the demo run while twisting the potentiometer to view the display. Then press the center touchpad to terminate the demonstration. Do not remove the flash drive while this portion of the demo is in progress. If the flash drive is removed while the application is writing to it, the flash drive will be corrupted. After exiting the demo, remove the flash drive and insert it into a PC. Use a spreadsheet program to open capture.csv. The beginning of the file will look something like this. The first column is a timestamp of the data. Each number represents one 10-millisecond interval and is the number of intervals since the demo began. The second column is the raw potentiometer reading. Use the spreadsheet program to graph the data column. You should get a graph that looks very similar to the one displayed real-time during data collection. Note that the data displayed on the starter kit's graph is not guaranteed to be at a fixed time interval, but is for indication only. The data captured to the flash drive, however, is guaranteed to be at a fixed interval and can be used for analysis. For other interesting applications for the PIC24F, be sure to investigate the other available menu options. The demonstration program on the PIC24F starter kit uses several freely available libraries. Portions of those libraries are included with the starter kit demo code, which is installed as a part of the starter kit installation. Application Note 1045 provides support for the FAT16 file system used on many flash drives. Application Note 1136 describes in more detail how to use the graphics library. USB support is described by several app notes. The key application notes for this demo are Application Note 1140, which is the USB embedded host stack, Application Note 1142, which describes the mass storage class on an embedded host, and Application Note 1145, which describes how to interface to a USB flash drive. If you would like to see examples of how to interface with the various libraries, please refer to the following source files in the project directory. The files PIC24F-starterkit.c, utilities.c, and games.c provide the best examples of interfacing with the graphics library. The files flash.c and demos.c show how to utilize the USB and the microchip memory disk drive file system with FAT16 support. If you would like to see examples of how to interface with the various PIC peripherals, please refer to these files used to create the demonstration project. The parallel master port interface can be found in the graphics library directory in the file sh1101a.c. The real-time clock and calendar interface can be found in the file rtcc.c in the project directory. The CTMU interface is in two files. TouchSense.c performs the keypad scan and interpretation, and Utilities contains the calibration routine. 3 output comparators are used in PWM mode in the RGB LED demonstration, which is found in the file demos.c. The PWM outputs are configured with peripheral pin select, also located in the demos.c file. The USB peripheral is used by various files in the USB library directory. Due to the complexity of the USB module and the USB specification, we recommend that you not access the module directly, but use the provided embedded host and peripheral device libraries. Go to the microchip website, www.microchip.com, for the full, most recent version of the libraries and application notes used in this demonstration. You can also find the appropriate datasheets and family reference manual chapters at this site. For more information about the graphics library, go to www.microchip.com/graphics. For more information about the USB library, go to www.microchip.com/USB. When you are ready to try your own application, or simply modify the demonstration project, refer to the Starter Kit User's Guide, which is installed in the Starter Kit's documentation directory. You can also refer to the extensive online help available for the MPLAB IDE and the MPLAB C30C compiler. Thank you for taking the time to view this tutorial. You are now ready to explore the capabilities of the PIC24F microcontroller.